Great. So hello to everyone. My name is Amit Davidson. I work as a senior software engineer for Palo Alto Networks. I live in Israel, from Tel Aviv, so it's like 2 a.m. right now, but it's Passover, so it's fine. On my free time, I love to bake and also to watch the NBA, but actually my side project right now is a tool called Chronos. Basically, it's a static race detector. So it takes your code and tries to find race conditions. You can later check it on GitHub. And as I mentioned, basically, static analysis is the topic of this talk. So what we'll have today? First, I will talk a bit about compilers and also about program analysis. Then we will talk about something called AST, and we can use it in Go. And this is the main part of the talk. And you will see how you can write your own analysis. And then we'll have a conclusion. By the way, I didn't mention it, but this talk is based on a workshop I gave about a month ago in GopherCon Israel. So if you would like to check out more, I will send a link to the GitHub repo in the end of this talk, so you can check it out. So let's start. By the way, feel free to pause me if you have any questions. I will stop from time to time to ask if you have questions, but because we are an intimate group, then just stop me and ask everything. So let's start. So what's program analysis? So program analysis is about analyzing the behavior of computer programs regarding a specific property. So what it means is like, so if you want, for example, to check for performance issues, this is our property, then we will probably use a profiler. If on the other end, we want to check for styling, then we would use a linter. If we want to check if our property maybe is a feature that it works properly, then we would use a test. So that's what it means to analyze a program, and we can do it in 2 or 3 different ways. One is without executing the program, which is static program analysis, like a linter, for example. Another way is during runtime, which is called dynamic program analysis, like tests, like a profiler, like Go race, if you know it, and a combination of both. So that's program analysis, and I'm sure most of you know it. Now let's talk about compilers a bit, and then you will see how static analysis fits inside the compiler flow. So what the compiler is, basically it's a computer program that translates one programming language into another, but primarily used to translate source code from a higher level to a machine code. So that's something we all know. And that's where it gets a bit more complex. So compilers are usually divided into 3 phases, the front end, the middle, and the back end. In the talk today, we'll focus on the front end, but it's good to know all the phases. So the way compiler works, most of the compilers usually work, is that the front end takes the source code. The source code can be one or many languages. For Go, for the Go compiler, it takes only Go, but if you know other compilers like the LLVM, that supports many languages. So it depends on the compiler. So the front end takes one or more languages, parses the code, and then creates something called IR, which is abbreviation for intermediate representation. And it's a language, it's an interface that the middle understand, and it can work with. So after the code is translated from the source code to this IR, the middle end takes this IR and starts to optimize it. For example, it does optimizations like constant propagation. So if, for example, we have an assignment to a variable and it says a equals 5 times 5, then there's no reason to calculate this in runtime. We can just calculate it on compile time, assign it 25, and that's it. And maybe we can use this variable later if it's used somewhere else. So we can keep calculating more and more. So this is an example for optimization. We also have dead code elimination. It's about removing unused code, for example. So that's what the middle end does. It creates this optimized IR and then just passes it to the backend, and its main responsibility is to translate to machine code according to the correct platform. So as I said, we will focus on this talk on the front end, and there the AST will fit. So let's see how the front end, let's see what it's made of. So it is also made of 3 phases: the tokenizer, the parser, and the semantic analyzer. And it works like this. The first thing that happens is that the tokenizer gets the source code. It gets a string of bytes, a list of bytes, you can say, a stream of bytes, basically the code, and assigns tokens to the characters. So it starts reading the code. It has V. It sees that V is an identifier. It identifies a variable, and it assigns it this token, V. Assigns this token, which is an identifier in the color blue, for example. Then we move on. We have 2 characters, the colon and the equal sign. So first, it says that it's a single token. So those 2 characters match a single token. And also it infers that the type of this token is operator. So we have the color pink. We move on. We have a literal. Literal is basically a hard-coded value, like a string literal if it was a string. In this case, it's an int, so we have 1. And then another operator, so it's the same color, the plus sign, and then 2. So from a list of bytes, we have a list of tokens, and that's what the tokenizer does. Really simple. Then this list of tokens is passed to the parser. And this is the first time we try to give meaning to our code. Basically, the compiler creates a tree-like representation. It's a tree representation of our code. It's called AST, Abstract Syntax Tree. And it represents the hierarchy of our code. So we can define this statement, this code, using the assign statement. So the assign statement has 2 sides: the left-hand side, which is V, the identifier, and the right-hand side, which is a binary expression, 1 plus 2, and we can even divide it into more. We can break it into even smaller tokens. So we can break this 1 plus 2 into 1 plus 2. So from this stream of bytes, which was then stream of tokens, we create this tree representation, the AST. Finally, we have the semantic analyzer, and it runs checks and then makes sure that this AST tree is valid. And those checks are really similar to what we will do today, what I will show you. But anyway, those checks, for example, one of them is type checking, for example. Type checking is about making sure that the correct types are passed around the program. So if you have a function that expects a string, then we don't pass an int by mistake. So in our code, it needs to infer types. So it infers that the type of V is int, and that's it. You may be wondering, by the way, why I mentioned that the final product here is valid AST. but earlier I said that the final product is IR. So that's, when you talk about the front end, those are the main phases. And there are actually more phases down the road, like converting the AST to IR, but those are the main parts. So this is the introduction about compilers. Any questions so far? Yeah, great. So let's continue. So now we'll talk about Go, which is why you came for. So let's start. Again, we will focus on the front end. So in Go, for every every phase of the front end in the compiler, we have a corresponding package in the Go standard library. So we have the source code, and the tokenizer in Go is represented using the Go scanner package. It takes a source code and creates a list of creates tokens. And those tokens are then represented using the Go token package. This stream of tokens is passed to the parser, represented using the Go parser. We have the AST, the types, and this one for the checks here. So as you can see, for every phase, every element in the front end compilation phase, we have a corresponding package in the Go standard library. You will see that when we will work with the analysis, then we will mostly work with the parser, and it will do the heavy lifting for us. So it will call the scanner, it will create the tokens, it will parse it and create the AST, it will run the type checking. So we will mostly work with this, but it's also possible, of course, to work with any one of those. So let's see the AST of a program in Go. So we have the following program, and it's really simple. It's just a really simple hello world program. And this is the AST of this program. So basically the top level element in this tree is a list of declaration, which is the file members themselves. And we have two. We have the import and the function declaration, those two. The import is made of basic literal, the FMT, and that's the left-hand side. On the right-hand side, we have the function declaration, and it has three properties: the signature, the block statement, and the identifier. So the signature is the signature of the function, the inputs, the outputs, all the types. So it's really, really simple, because here it doesn't receive anything and it doesn't return anything. So it ends here. It's really simple. We also have the identifier. So you might be wondering why we have maybe the identifier, although usually in the signature we also have names. So actually this is the main. It identifies a function. So if, for example, we have a lambda function and an anonymous function, so it will have a signature, but it won't have an identifier. So that's why we have both the signature and also the name. And finally, we have the block statement. The block statement is the code itself. It's a list of statements, and it has one statement, which is a call expression, and it's this one. It has two branches. One is the parameters, the hello world, which is a basic literal as earlier. And on the other end, we have the selector expression, which is a special kind of function call, and it is made of the FMT package and the print line. So this is the AST of this program. It's very verbose. Any questions? Great. So let's focus a bit on the AST package in Go. So let's take one of the types there, one of those types that are defined inside the AST package. So we have this index expression, and index expression is how this struct is represented in Go. So the index expression has the property x. X is what we do the index operation on. So in this case, it's a. We have the left and the right bracket. And those are just the position of the brackets in the code. And as you can see, token.position is an int. And in this case, the left bracket is 2 because this is 1 and here it's 2. And for the right bracket, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 11. So the position is 11. So that's also simple. So we cover the x, the left and the right bracket, and finally we have the index. And the index, it's the index you want to access, and the type is expression, and that's because you can provide the expression. And when talking about expression in programming languages, it means everything that returns a value. So in this case, we have we take the last element, but it's a value that is determined at the right time. So that's why the type is expression. And that's about index expression. We'll take a look just at another type. So let's say we have the assign statement. We have the left-hand side and the right-hand side. As you can see, the type is a list. Is a list of expressions, because you can maybe have if you have a function that returns multiple values, so you can have multiple elements to the left. And if you do, for example, maybe a swap, you swap variables, so you might have multiple expressions to the right. You also have the token position as earlier. In this case, it's 3 because 1, 2, and 3. And finally, you have the type of the assignment. So you can have any of those. So that's another type. And we have many more types in the Go standard in the Go AST package. We also have many interfaces, and we also have others which don't fall exactly into one of those. So far we've talked about compilers, program analysis. We also covered AST and the Go packages. So it's finally time to see how a simple analysis looks like in Go. So we have the following program. Basically, the first statement is just variable declaration. We defined we assigned a new program, just the hello world from earlier to SRC. And then the first line right after is the F set. So basically we define a new file set. And so what's a file set? Basically so what's a file set? Actually, before that, I didn't mention what this analysis does. But basically, here we have an analysis that takes a source code, that takes a program, and tries to find if hello world exists inside this program, inside this string. And if it does, it locates where it is and puts it to the screen. So yeah, that's what this analysis does. So let's continue again. Basically, the first line is a new file set. So what file set is? A file set is a data structure used internally to represent the positions of tokens inside the Go program. It relates to the token.pos we worked with, we saw earlier. So let's see how it looks like in a real program. Let's say we have this program and it's made of 3 files, A, B, and C. The base, of course, is 1 because we start from the beginning. And the size of this file is 50, so we have 1 to 50. file B starts from 51, then 20, file C is from 71 and 130. And let's say we have a token and its position, the position token.pos is 74. So this way we can easily determine in what file and inside that file exactly where this token exists. So for 74, we can see that, of course, it's in file C. And then we can subtract 71 from 74, which is 3, to realize that this token is the third from the beginning of the file. So this way we can use the token.pos from earlier to understand exactly in what position in the source code the token exists. So that's what file set are used for. So we pass the empty file set to the parse file. And as I said earlier, we will mostly work with the parser. It will do everything for us. So we pass the empty file set, and then we pass it our code. And this just means, this is the path to the code, but because we provide the code for a variable, then this is an empty string, and this is the code itself. And finally, this is the build mode. 0 is the default, but you can provide different build modes, like maybe to ignore comments when the files are parsed, or maybe to parse only the imports without without the function themselves. So those are different build modes, but we use 0 because it's the default. So we parse the file, and finally we have the logic, the body of the analyzer. So what we have here, f is returned from here. F is the file, and this is the root node of the AST of the tree, and we pass it down to the AST inspect. So let's start and talk about what we have here. AST inspect is, if you will write analysis in the future, this is the most important function. This is the way you traverse the AST. So it starts from the root node in a DFS in a DFS way. It visits all the nodes, and on each node it runs a visitor function. So in our case, this is our visitor function. As I said earlier, what this program tries to do is to take a source code to find out if it has the hello world string, and if it does, to print it. So we need to run on every node and see first that it's a basic literal, it's a string. Because if it's not a basic literal, we can just continue. So that's what we do. Then we check to see if the value of the string literal is hello world. And finally, if we have a match, then we take the position of this node. So we take the position and we pass it to the file set. So this is, the entire flow of how you get the position from token.pos. And then you just use the line and the column, and that's it. Maybe one final word about the false and the true. So the false means that you can stop searching. We found what we're looking for. You can exit. Whereas the true means continue iterating, continue traversing the tree. We haven't found what we're looking for. So that's the false and the true. Any questions so far? Okay. Just a moment. So now I want to show you basically how a real analyzer looks like. So this is an analyzer I wrote earlier. And basically what it does is it takes a source code. takes a source code and tries and finds basically places that we modify parameters that we got from our that basically it finds functions and looks to see if we have places that we modify arguments that we received in the arguments. So for example, let's say we have this retry function and we get the amount of times to retry this function. And each time we retry the function, we run the function, then we decrement the amount of retries. So it's perfectly legal, but the only problem that if someone tries to debug it, it's hard to determine exactly with what number of retries we started at the beginning. So this is mostly a personal preference. So I wrote an analyzer that does it. And basically what it does, let's look at the visitor function, because we have, many things around it. So the visitor function, the way it looks, we pass it to the inspect, and then first we tries to see that we try to convert it to a function declaration, which is a regular function, or a function literal, which is an anonymous function. And if we don't have a match, then we return, we keep iterating. Then we make sure that those functions as arguments, because if we're not, we can just continue. And finally, we just iterate over the variables. This is those two lines. Basically, this means to iterate over. Basically, this means to iterate over each of those. This line, and then inside each of the list of parameters, then iterate on the names themselves. So then we iterate over these separately. So these are those two lines. Then we iterate over the body, because then we iterate over the body, we find places that we that we find AST types that means that those are places that we modify something like a sign statement, or maybe init text statement like plus or minus. And once we have those things, then we check if to see if it exists inside if the argument that we modify here is basically exists in the function parameters, and if it does, then we flag it. So that's a real life analyzer, and as you can see, it's really simple. We don't have many lines of code here. It's really simple. And for example, for this function, if you will run it, we'll get this message. Basically, that on this file, on line 9, on position 1, 2, 3, and 4, we overwrite one of the function parameters. So yeah, so that's it. Any questions? Okay, great. So just we'll have a conclusion. I just before I finish, I just wanted to show you maybe other programs that do similar things. So we have GoFMT, which is a built-in tool, and I'm sure everyone knows it. And what it does is, it checks for indentations, for empty spaces. It goes over the source code itself, the raw source code, not the AST. So it's a bit different from what we did so far. But then we have GoVet, and GoVet is really similar to what we did today. It examines the AST table as opposed to the raw source code, and it does many checks. Like, for example, if we have a string formatting, then to make sure that we pass the correct types. So that's GoVet. We also have Go imports, and for example, Go imports, it does everything that Go FMT does, but it also, for example, check for the order of your import. So it also needs to look at the AST of your code. So that's, for example, Go imports, and it's another tool that works with AST. And when talking about tools from the community, so we have this awesome list of different static code analyzers, and there are many code analyzers there, and they are really good. You should check it out. We also have static check, and static check, it's like a mega package with many linters, many different kind of analysis, and it's really similar to Go vet. It does many checks, like forgetting if you maybe call the mutex.lock, then it makes sure that you remember to defer it right after with unlock. So checks like those, again, on the AST. Maybe Golang lint CI, it takes many linters, runs them in parallel. It uses caching, and basically it takes most of the linters here and make it possible to run them, because otherwise it will take many time. So that's Golang lint CI, and finally we have Chronos, which is what I wrote. So you should also check it out. If you want to read about it a bit more, then maybe you should check the workshop. It's on my GitHub profile. It includes a deeper, so it includes more topics about static analysis, and also more information about AST. So you should check it out. You can also read more about AST here. It's an official document, and it basically explains about AST and in general all the other packages I mentioned earlier, the Go scanner and the Go tokens, and the entire front-end compilation in Go. So you should check it out. It's really interesting. And the Go analysis API package, which is the standard way to write analysis. So if you ever want to write your own analysis, you should first check out this package, see how analysis are written, and basically use this package to implement the API mentioned here. So that's it. Do you have any questions?
Hey, Amit, how are you? First, thanks a lot for doing this at 2 in the morning. It was really good. Yeah. A lot of it's like way over my head, like all of it. But essentially, if in like in my HTTP handler or something, I have some kind of shared data that I didn't properly put up, that becomes a race condition because I didn't put it, lock it with a mutex or something like that. I currently today, like I would fail to find that because I'm not really good at using Go race, right? Because you got to feed Go race a bunch of data, right? And in order to understand if you have race conditions, right? And it's easy to miss. Does your tool Chronos, like, does that help solve that problem for me? Like, do you know what I'm saying? Like, will yours pick that race condition up, without having to like feed it a bunch of
so stuff? I will say 2 things about it. So Go race is dynamic program analysis. So you have to set up your system. You have to feed it a live data, and that's for dynamic program analysis during runtime. Where my program is static, so you just have to provide the code and it will find it. So that is the first thing. The second thing is that it doesn't really work on big code bases, and so it probably won't work on your code unless it's really small. So yeah, sorry to, yeah.
Got it. Cool though. It's neat. I appreciate it.
But you can check out the code.
Yeah. I definitely will. Thank you.
First of all, thanks to Boston Golang organizers to let me talk to you about my side project with Go. And obviously, thanks to all of you who are listening me, and I hope you're all doing well. So before dive into the subject, let me introduce myself and make my self-promotion to you. My name is Sylvain Combraque. I'm from Lille in France. Then sorry for my baguette accent, but I try my best to speak as well as possible. I'm traffic contributor and also the creator of the cache system we will talk about. And you can find me on GitHub searching Darkweek and Darkweek Dev on Twitter. So let's replace the context of why I started to dev using Golang and how I came to do it. As I said, I'm traffic contributor since 1.4 and helper for this. Then for those who doesn't know traffic, it's a reverse proxy created to manage container architectures, and it's a container first approach. It supports the hot detection deployment, the scaling, it load balance the request for you using the weighted round robin, and it uses only a specific port for all protocols. Then traffic manage for you the service resolution depending host in entry. Then it's a pivot point of your infrastructure. It's like Kong or Nginx for those who have already worked with them, but really simpler to configure and set up. Another good point is the fact you can install it on your development environment and continue your work instead of bigger reverse proxies. Then, as you can hear me, I like to use traffic, but after months to use this solution, there was an issue I was facing too. There wasn't any cache system internally to traffic. Then all requests would have to resolve the associated service. Then it took many milliseconds to be done. And I searched after a cache system solution, but nothing appeared to be as efficient as I wanted, or it was only POX. So after many nights spent to look after that, I decided to create my first program in Go. And the fact I was totally noob with this language, but it didn't scare me because for a project, when you have a goal, you'll do your possible to achieve your goal. So that's how I came to learn Golang. And this project is called Sylvain and is actually in 1.4.4. And for the record, the release names are open source beers because I like to drink beers. And don't forget to leave a star to this project because I've got an oversized ego and it makes me happy to see the stargazers count growing. And for the troll, for those who are using Varnish, there is an illustration to show you how Sylvain is versus Varnish. So let's see together how it's easy to set up through a demo. I'm in a folder with a docker compose.yaml file and a configuration YAML. If I try to show you the docker compose YAML file, we are defining 3 services. The first one is traffic. The second one is who am I, which will expose some information about the container. It's linked to the domain.com URL, and obviously Swan instance to show you the cache system. And if I show you the configuration.yaml, we are defining the default cache key, and we are exposing only the HTTP port with a lifetime of the cache of 10 seconds, and we are linking our cache system to the traffic instance. Then if I start it, we can go on domain.com, and if I try to reach the container, it took around 22 milliseconds. And if I refresh, it took around 3 milliseconds, and it add an additional header X from cache to tell you Swan handle the request and serve it. In the future, this header will be replaced with cache status header. So it will change. So now let me explain how to build fast applications with Go and specify in my case what kind of Go features help me a lot. So first, I can't talk about Golang features without mentioning the Go routine, but I think everybody in this meetup have the everybody are knowing Golang, so I don't have to redefine this. And so I'm using Go routines to avoid the time consumption and run really cost-effective functions like the update cache eventually, because it has to validate the headers, check the RFC, etc. And here I don't get back the results because I don't need it. Then the another big feature is the channels, because we have to discuss in our Golang applications between Go routines and the main thread, or between Go routines only. So the channels help me a lot, and I use this to thread the incoming requests, for example, and be able to coalesce them if needed. And only when the response is available, I'll return it to the client. With that, I can manage multiple connections at the same time. And it's really helpful to use it. So as a channel has its own type, we can use here, for example, the reverse response type to only serve this. So after that, I was facing an issue with Go. So in Go, the first version, it doesn't support generic types, but it will do. It will done at the second version of Go. So at the moment, you have to find some tricks to be able to pass a generic object as possible. And the solution is to apply the dependency inversion principle to decoupling software modules. And thanks to Wikipedia for the definition. And use interface instead of the implementation. And it's a little bit tricky in Go to implement an interface because sometimes you can implement an interface under the hood without knowing you're implementing it. Then in Swan, we have some providers to be able to let the user decide which kind of storage system should be used, depending the matched URL in the full version. And here we are defining the type of each provider. Each provider defines some functions like list keys, get, set, delete, and init. And recently, we introduced the reset function to be able to reset our provider. And they have the same signature for each provider. And to make a generic object, we can define an interface like the abstract provider interface, which will contain the method signature and each structure defining all the functions with the same signature will be considered as implementing the interface and can be part, for example, of an abstract provider interface. So after that, we can pass our Redis or our Ristretto provider. And as the two structures are implementing the interface, it won't crash, and your IDE will propose to use the auto-completion for an abstract provider interface and not your real object. So you have to parse it if you want to use your real object instance instead of the interface. And I know the pure Golang users doesn't use the IDE, but I'm younger and I like to use it. So the power of Swan compared to Varnish is configuration, which is simpler than the VCL or Varnish configuration language. And here you just have to define a YAML, and it works like a charm. On the left, you can find the minimal configuration to be able to run a Swan instance. And on the other side, you have the full configuration for the full version containing a Redis provider and other many keys. Then as it's YAML, you can use anchors. You can write script to create dynamically the configuration. And the most of all, the configuration supports the hot reload. Then you don't have to restart Swan if you change the configuration. But I plan to disable by default this feature in the future to avoid memory leak and because it makes a side go routing running to listen the file changes and reload configuration when the file is saved. Then keep in mind that existing keys are always stored and available in your providers and will be purged only when the TTL reach 0 and your key expire. Or if you decide to purge the cache by a reject or URL directly using the API, but we will talk about it later in this talk. So as traffic, Swan is container first designed to be compatible with as much as possible with existing systems. You can define a Docker Compose file for Swan exposing the needed ports and map the configuration file path. And be sure the reverse proxy is in the same network than Swan instance to avoid external requests over your network. This is the configuration for working with Swan out of the box, but there is an available KDE module and a traffic plugin which will be released when they'll support a plugin that use the unsafe library. And I hope this day will arrive soon. So this part was really fun to dev, but I was facing the most complex parts. And the first one was the RFC implementation. And support the RFC rule is really good to face and fight the depression, because you think you're done with that, with the support, but another rule in the RFC comes and you have to rewrite part of your code, and it's endless. So the RFC for request for comments designs the semantic of the web and apps to homogenize and define standards of your responses, your behavior, and don't let the creator be free about implementation, about the logical parts and data processing. And here is an example with the RFC 7234. And this is only the first page, and there are 42 another pages to read. And that was a pain to support that, but thanks to other developers that implemented it in the past, then I can take advantage of their existing work. That's the magic under the open source. Then when you're implementing an RFC, you realize that just if-else conditions, you can see in this example to manage the cache control header, it just condition over others to be able to test every cases. And that's the same thing for the expire header to check if it had already expired or always good to be served, for example. Another cool feature in Swan is the support for the request coalescing. That means when you get multiple requests at once on the same route with the same context, you'll temporize all incoming requests, and you'll request only once your backend, then use the same response for all temporized requests. That's pretty cool because your backend service can be on a cheaper server like a Raspberry Pi. And if it couldn't handle all requests if it was on frontline. And to achieve that, thanks to Single Flight for providing a library that can be used to handle and coalesce requests. So as Swan takes care of users and want to let them manage the cache through an API, it provides some endpoints and secures them with authentication. At the moment, you can only list keys to avoid content leaking and purge cache for resource or multiple by regex. And let's see together how it works and how I did it to make it as faster as possible without impacting the base cache system. First, the configuration about all the API endpoints are the following. You have to define the API block in the YAML configuration file. Then you can override the main bus path, which is Swan API by default. At the moment, Swan supports only 2 APIs, but in the future, it will support more endpoints. For each endpoint, you can override the bus path, tell if it's enabled or not. And by default, all endpoints are not enabled. Then specifically for the security endpoint, you are allowed to define a secret on a list and a list of users to be able to log in as these users. And for the Sylvain endpoint, you can tell that you want to protect related routes behind JWT security firewall. So for the cache management, the default bus path is Sylvain, and you can send a GET request on the base endpoint to list stored keys, or send a purge request on an ID, or regex to purge it. And here are some examples about the results. When you are sending requests on this endpoint, as you can see, the bus path route returns an array containing all keys stored in the provider, and on the full version, it returns all keys for each enabled provider. Like you can have Ristretto with all keys stored in Ristretto. For the Redis part, you'll have Redis with all keys stored in Redis. And if you implement your own provider, you have your own provider with all keys in this provider. Then the purge regex path returns nothing. Expect an HTTP no content if it reach successful. So as I said, Sylvain provides the JWT authentication using JWT token, and you can log in on the login endpoint, sending a post request with a JSON content type header and the JSON body containing the username and password. Then you can refresh your token, sending a single post request with a JSON content type header and a cookie named Sylvain authorization token, which contains the JWT token in it. So here is the result about the security API endpoints, which are located under the bus path authentication by default. The login request set an HTTP cookie if authentication is valid. Then the refresh endpoint return a new HTTP response, which tells that the previous cookie should be replaced by a new one. But you can tell you in your mind, okay, it sounds great, but I want to know how to code this. So I'll tell you the magic under the carpet. Basically, I get the main bus path from the configuration. If it doesn't exist, it will use the default value Sylvain API. Then after that, I load each endpoint using the initialize function, which take a provider and the configuration in entry. If the endpoint is marked as enabled, I just create an HTTP handle func with and without the trailing slash. And each endpoint have a property named handle request as the name specify to handle the incoming request. Then the path is built from the the concatenation of the main bus path and the endpoint bus path. This code is running at Sylvain startup only, and it takes only some milliseconds to be executed. So at runtime, it doesn't affect the performances. Then the last really tricky part is the key management. Ristretto doesn't have a function or a property containing the list of stored keys. Then I had to declare it out of the Ristretto library. I called it key saver in the Sylvain code base. I didn't have inspiration to name it and with another terms, and because why not name it like that? So then the key saver is basically a Go routine, and all actions on it will be run inside it. The get and set functions are asynchronous. And with this approach, I don't have any problems with concurrency as I try to write something in the array while I'm reading it. So thanks to the rlock and runlock functions to ensure nothing can edit our list while we are accessing it. So after this very long technical part, we can now talk about the deployment system. The deployment is secured by Travis CI to avoid regression. Then the GitHub actions get back the lead to deploy only tagged versions on master and full version branches. First, the workflow for deployment on a tag branch or master is the following. Tests through Travis are launched, then the artifacts are built, and the last step is to upload artifacts on the tagged commit to be able to download the OS and Arch associated binary. Here is the diagram to try to represent the Travis CI setup. I'm not a designer, so this diagram is really ugly. And here is a configuration file about it. Let's see together what's done on it. First, I tell to Travis to boot with a Golang environment. I add the Docker dependency to be able to run required containers. Then it ensures the compliance with every systems. I don't send email because I don't want to be spam. And after this, Travis will run the create network command to add the associated network and run the build dev to build the development containers and be able to run the test after that. And it runs the validate command, which will group the linter verification. If it succeeds, it will run the test to handle any regression. And after that, we check that the production mode can be built and won't crash to ensure the compliance with users that use the latest Docker image. So after that, once it's merged on master, then tagged, the GitHub actions will be called and two jobs will be running. The first one is a binary generation to create artifacts depending the OS and Arch. it retrieves the tag name, pulls the tagged branch, requires the dependency of Docker, and enables the build system to be able to build Docker images. After that, it tries to log in at the Docker Hub using secret credentials and build the prod container using the Dockerfile prod, the Dockerfile prod, and push it to the Docker Hub as latest full and tag branch name as image name. The only one line which differ from the minimal version is the 33rd line. In the minimal version, we are using latest label instead of the latest full tag. And as you can see, here is the result on the Docker Hub. Our image is tagged as latest and is ready to be pulled, and obviously it's tagged as latest full for the full version. Then the last step is the artifacts generation and upload them to the GitHub release through the Go release action. In this example, we build for Linux, Windows, and macOS to handle most cases and use a matrix to build the tool for Arch. And as you can see, again, we have our artifacts on the refilled releases. Then this is my face when I release a new version. And just for those who want to see what is the power and performances of Swan, here are some metrics to view how many requests it can handle per second. It took around 35 seconds to serve each 100 and 1000 requests. The max response time was only 56 milliseconds, and the minimum was only 0. But it took around some microseconds to be done, but it's rounded to 0 milliseconds. And these results are due to Ristretto powerful in combination with the asynchronous updates. So after that, what's next in Swan? First, there will be full support of Barry because it requires deep refactoring about stored keys, and it will take time, but it's a priority, and be sure there wasn't some security issues. Then we will work on the fact Swan shouldn't try to coalesce requests on an endpoint that has already returned a private cache directive. And after that, I support the new RFC cache status to replace the X-from cache header. And there is always the work on performances because this can always be optimized. And feel free to open an issue if you have some ideas to implement or if you have some question. So I'm open to all of question on it. So to finish my talk, I just want to say again, thank you to Boston Golang organizers and all of you. Don't be shy. You can ask me whatever you want. I try my best to answer it. Anyway, I'm available on Twitter if you find some question during the night, and I will be available on the Slack. So, like Gordon Ramsay is saying, thank you so much to all of you.
Sylvain, thank you for that talk. It was great. So thank you for staying up so late as well. One question I have is, maybe you went over it and I missed it. It's like, why did you follow the RFC? Why do you have to do that?
I missed something of your question. But,
yeah, did you try to implement the cache based on the RFC documentation? Is that why you keep going back to that? Maybe you mentioned this already, but I forgot. I didn't hear it. So
sorry, my English is very bad.
Oh, sorry. Maybe you can hear me correctly. So you referenced the RFC quite a few times. So I was curious why you did that. Are you implementing that based on RFC on the cache, or is that something that you decided to do it?
The RFC isn't totally supported. I plan to do it, but it takes some time to do, and I'm trying to find some libraries to avoid the reventing of the wheel. But expect the Apache library, which supports the cache, the no cache either. There wasn't any other library. I don't know if it answered to your question. So.
Kind of, yes, but that's okay. Thank you. Yeah.
Okay.
Yeah.
Sorry.
Sylvain, I think there's actually a question on the chat. Someone's asking if you picked Gordon Ramsay because it starts with Go.
I picked Gordon Ramsay because before I used Trump GIF, but it's a little bit touchy, so that's why I changed it. So, but Gordon Ramsay is a good guy.
Ooh, can you actually? Oh, are you seeing my screen? Are you seeing something which says Visualize IT?
Yeah, we can see it.
Woohoo! Okay, so I'm not sure I can see the rest of you, but okay, I do. All right. So hi everyone, and thanks so much, Andrew, for kind of inviting me to this. I might have gate crashed your meetup, but I'm a long-time organizer myself, and I really love meetups and I miss community, so I'm really glad to be here. So my name is Nitya Narasimhan. I'm a member of the developer relations team. I'm a senior cloud advocate at Microsoft. And my background is actually in mobile and web development and distributed systems. But a long time ago, I had looked at Go. I haven't touched it since. But I'm going to talk today about something completely different, which is peripherally related. But I hope you'll all listen and take notes and maybe kind of even use it. So I call this talk Visualize It. It's actually Visualize It or Visualize IT, depending on how you think about it. And really, it's two things. One is learn to sketch, and then the other side is sketch to learn. And hopefully at the end of this talk, you'll know what I mean. If you want to keep track of it, my Twitter handle is @Nitya. I would love to hear from you. Just hashtag visualize it or just tag me. You can find all the sketch notes at cloud-skills.dev. It'll be a little slow because these are all really big files. And you can also follow @sketchthedocs. That's a no spam account where you'll only see sketch notes. So let's get started. One of the reasons I got into sketch notes is anytime I go to an online event, anytime we kind of think about Twitter, right? There's a whole bunch of text out there. And one of the things I do is I look at how do we communicate stuff in a way that is not only accessible to people, but is understandable by really diverse audiences. So this is one of the slides I always put up. This is basically Keith Haring style, like, a community slide that kind of tries to represent all the things we do. But you'll notice two things. The first thing is the minute you see this, it's colorful, it's creative, and you kind of can immediately take some messages in there, right? It's like we belong here. So think about the ways you could use visuals to improve your presentation, but we want to go further. So what is visual storytelling? I keep using this term, visual storytelling. At a very high level, what you see on the right side is actually one of my, what I call a high-res sketch note. And if you look at it, what it's really doing is it's using a visual vocabulary. That means that it's everything in there, it's colors and icons and fonts and imagery, everything giving you a big picture, right? So it's using a visual vocabulary. Why? To communicate complex ideas. Why do you want to do it with this? So that you can help people understand, retain, and recall that information. So we'll talk a little bit about that, but first, why? That's what visual storytelling is, but why should you care? It turns out that there's a statistic that says 65% of us are visual learners. One of the things we realize in tech is, as an example, my PhD was in distributed systems and fault tolerance. Haven't used it at all. I haven't even looked at Java for the past 10 years, right? Tech moves so fast that you constantly have to evolve. That means we all have to continuously learn. So when you think about visual storytelling, we all learn differently. Some of us learn by reading books, some of us learn by doing tutorials, some of us learn by listening to lectures. 65%, 2 out of 3 of us learn by looking at things, looking at the big picture, connecting the dots, looking for patterns, and then use those to kind of apply them to our own problems. So 2 out of 3 humans learn visually. And so as a developer advocate, I need to go where the learners are. If this is how you learn, I want to make sure I can give you information in a way that makes sense to you. The other side of it, and this is something that I found super interesting. This is an article that came in KQED recently, so that's the wrong attribution. I have to change it. But it basically talked about, I think it was called How Sketchnoting Can Help with Zoom Fatigue. And it was educators talking about like this 1 year of the pandemic, right? They were saying visual storytelling, sketchnoting is suddenly a big deal to them. Why? Because they don't know whether their audience is interested. So what they do is they assign them visual note taking. They're like, take notes visually and show me what you learned at the end of it, right? So doodling meeting visual language, that's kind of where sketchnoting falls into play. And what sketchnoting does is it does 2 things, right? First, it helps you as a learner, it helps you organize and retain information. But for the teachers, it helps them check in. What did the student understand? Did they really take away what I thought I was telling them? And so you, as someone who's in a technology space, who's going to be doing talks online, think about it. If you want to communicate stuff to your audiences or want to know what they took away, this is a way you can think about it. So my visual storytelling journey actually started with self-care. Many years ago, I burnt out, like we all burn out in tech again and again. And it turned out I was like really running at a mad pace. And I started drawing. I always used to draw, but I did it with intent because it helped me cope with anxiety and stress. It slowed me down. It helped me focus. And that's where I started. From there, I went to journaling. Like I would literally go around carrying a notepad and I'd be doodling all the time. When I joined Microsoft, I announced it with a doodle. That up there is my son, right? He was really mad with me and I was still drawing away. But I remember these, right? I never have to think about them. I will remember these instants forever because I was capturing them. Fast forward to when I was going to conferences as a speaker, as an organizer, as a volunteer, whatever it may be, I was starting to sketchnote and share what I sketchnoted, right? And it turned out I would meet interesting people because we'd end up seeing similar perspectives. So in tech, I kind of look at this journey taking me finally to tech storytelling, where I see a roadmap. And that's the thing I've given at the bottom. The roadmap is start with note-taking, where you're really trying to capture information, then evolve to what they call anthropomorphism, which is being able to tell stories where people are connecting to the message because you've added characters and emotions. And finally, the most powerful weapon of all, metaphors. If you want to teach something to someone, try to explain it using a concept they already know. So those are the 3 tools that I think of as my visual storytelling roadmap. So this
is quickly interrupt. We are still seeing the first slide, and I just want to make sure that the screen is supposed to update or not, maybe.
Oh, it is. You're not seeing all the slides? Oh my God. I'm like on the 4th slide. What happened?
We are still seeing the first intro slide.
Oh my goodness. Give me a second. Then we are totally wrong here. Sorry, folks. This is what happens when I Zoom, I guess. Give me a second. You all okay with me taking a second to like readjust my screen?
Sure.
I have no idea why it picked that up. And then you need to tell me where I started or stopped, but let's see whether this will work. And whoever it was, the brave soul who spoke up, thank you. I appreciate it. All right. Let's see. Are you seeing the screen? I mean, are you seeing my slides?
Yes, You see the first
Are you still seeing my slides? Are you seeing something that says what is visual storytelling?
I still see the first slide.
Oh my goodness, what is going on? You know what? I'm just going to share my whole desktop. Okay, that might make life easier. Give me a sec. So you were all listening to me talk for hours on one slide, and you must have thought, oh my God.
I think earlier, just now when you shared, we were able to see the main slide and your list of slides on the left. So I don't know if you just want to go back to that view and click on the slide.
Yeah. What I'm going to do is I'm sharing my entire desktop now. You see that?
Yes.
You do? Okay.
At least I do, and I can see.
Does everyone see it?
Yes.
Okay. You know why this is a joke for me, right? Because I'm literally telling you about visual storytelling and you couldn't see a thing. Oh my God, this is so embarrassing. All right, no worries. I was actually on this slide. So if you missed it, this is the thing I was talking about. This is what a sketch note is. So when you think about visual storytelling, I'm thinking about sketch notes. Do you see like an image on the right side, which is this giant kind of like high fidelity video, like notes of a particular topic? Okay, so that's a sketch note. And so when you do sketch noting, you're using a visual vocabulary. So you can see I've drawn a lot of icons that are fonts, that are colors, right? To communicate complex ideas, to assist with understanding. And this is the slide I was talking about where 65% of us are visual learners. So this is why, and I'll share these slides later so you can always catch up. But this is where I was like, you know, one of the reasons why it's important to me now that we all start thinking about this is we're all going through a pandemic and our audiences are all online. We have no kind of like, you know, there's no other way. And turns out that visual storytelling, this was a nice article which showed that teachers were using sketchnoting as a way to check in on their students. So I kind of look at sketchnoting as a way to teach, but they were also looking at it as a way to test what their students learned. So just as a soft skill, just like public speaking, my goal is to make sure everybody sees visual storytelling, sketchnoting, all of these things as a tool they should have in their communication tool checks if they're doing stuff online. So let's go to the next one. Forget my journey. Forget this too, because this is just about like all the stuff I've been doing at Microsoft. It's been like very, very popular. I'll just put it that way, right? And the thing I want you to take away from this is there are 4 different categories in which I think this has value in technology as an advocate, as a community person, right? One is what I talked about, which is sketchnoting 101, which is just learn to sketchnote. If nothing else, it's a skill you have, right? But the second part, which is visual storytelling, is how you can take that learning, that toolkit, and start applying it to various areas. One of them is to actually use it to create your talks. And I'll give an example later. Second one is I've had a whole bunch of workshops we did recently where different people came in and showed how you could use that tool for digital journaling, for graphic recording. It's a full-time career, by the way, that one, for basically public speaking, right? So there are various things you can do this for. I put a couple of other examples. I sketchnoted Satya Nadella, who's our CEO, his talk at Build. He liked it. And then his folks came back and said, this is really good. We'd love to see you do more. Charlotte is one of our CVPs, same thing. In her case, she was like, could you actually sketchnote my journey in tech? And I'll use this as an introduction slide for various folks. So it kind of showed me that these have a really good way of communicating ideas to people, right? So what is sketchnoting? Sketchnoting is the first step in visual storytelling. Remember that. It's sketchnoting and then anthropomorphism, and then you go into metaphors. So sketchnoting is rapid note-taking. You capture ideas really quickly on a note sheet or on a digital iPad. And the real value here is bringing your own expertise to the problem. So as you're writing, you're not just writing whatever they say, you're synthesizing this in real time and starting to take shorthand, replacing it with things you know. So this example where you see me, I'm literally sketchnoting at a conference. That image you see in the background is what I was drawing, right? And you can kind of almost see that I've got a phone, I take quick pictures, I'm like writing, I fill in the blanks later. But at the end of that talk, I've distilled 45 minutes into a single sheet. What's next from once you learn sketchnoting is these 3 steps. First, start getting people to connect to the message that you've sketched, right? The first one just captures information. Now you can connect by adding characters. You can convert knowledge. You can get them to take an idea you've explained, but by connecting it using a visual metaphor to something they already know, you can literally make them understand a lot more stuff than you would otherwise. The example I always give, and if you go to my account right now, you'll see it, explaining cloud computing, all those concepts in cloud computing using a truck metaphor, because cloud computing is the delivery of services over the internet, right? So I'm like, great, delivery, let's get on that word. Truck delivery, everybody knows about truck delivery in the pandemic, right? So it's like, great, what if I used a delivery metaphor and explained all the concepts? And you know what? People understood it. It's one of the most popular articles I've ever written. Last but not least, vocabularies. If you're in so I'll give you a Go example at the end, but if you're in, like, say, healthcare, you'll have a certain set of icons and imagery and words that you want to use. If you're in kind of retail, that might be different. So understand your vocabulary, learn to sketch the things related to that vocabulary. So I'm going to do a speed read, and Andrew, tell me if I'm running late, because I don't want to it's really late for everyone I know. So I don't want to keep you up too much, but I'll try to run through this, and then I'll really talk to you about examples. And if I get a chance, I'll show you where I'm at with the Go visual guide. Is that good?
Oh yeah, totally. No worries about time. This is an awesome talk.
Okay. I tend to talk a lot. So anyway, so first part of this talk is we're going to learn to sketch. So if you have a pen and paper, feel free to follow along. But what I really want to give you is your first steps into, it's like your toolkit. How do you build your own sketchnoting toolkit, right? So step number one, it turns out we all innately have the ability to draw. We all have it. Like, you don't need to be an artist, right? No one's asking you to be Picasso, but we all have the ability to take ideas in our head and jot them down. We all do it. As kids, we do it without thinking. As adults, we start rethinking what we're doing. So step number one is stretch your sketching muscles. This is what I do every day. If you can see it, this is an animation, simplest stretching exercise. It comes from this book called The Doodle Revolution that you can actually see in my shelf. And it comes from Sunny Brown. She's done research in a TED Talk on this. And she makes the case that doodling is really about deep thinking in our heads. As we doodle, our brains are focusing on a problem. That's why we do it. So her thing, and I really like this, is take a piece of paper and just draw squiggly lines, get them to cross over each other multiple times, and then start filling in the intersections. Use colors, use hatches, whatever you like. But this is the equivalent to like stretching your muscles before you start running, right? So you just kind of do something creative. It loosens up your brain, and you start kind of having this free flow of like, what can I do? So every morning, I literally do this every morning. You'll always see me drawing stuff. 5 minutes, doodle. If you get into a meeting, spend 5 minutes, doodle something. You will find yourself being able to focus better, and your brain will subconsciously be processing information. Once you've got there, the next step you want to do is really start building a visual storytelling toolkit. These are the components I'm going to talk about. So on the right-hand side is an example. It's not perfect, but it's an example of a sketch note. Again, I'm going to play it. It's like the simplest one you can do, and you can see that it's not pretty. It's just like, but it's functional. If you look at it, you know, those are people, that's a roadmap, that's a banner, those are arrows. You can tell that that's all we want, right? So these are the different things that we're going to talk about that are parts, that are tools in your visual storytelling toolkit. Fonts, quotes, people, icons, containers, layouts, direction, and colors, right? And you can see elements of all of them in here. I'm going to go through each of these. The very first thing you want to learn is fonts. What does that mean? So with fonts, remember that visual note-taking at the core is really about writing. Nothing matters. You can look as pretty as you like, but if people can't read your information, it's useless. So first and foremost, you want to think about practicing your handwriting to write fast and slow. Write fast to capture information. Nobody can read your chicken scratch, but if you can read it, that's all you need. Then you can come back later and refactor it, meaning copy it out cleanly and slowly for clarity. Or if you're on a digital iPad, you can erase it and replace it with slower letters. When you write slow, you're always more legible. Okay, so fast for capture, slow for clarity. But once you know about handwriting and you've gotten into like good handwriting, you're going to use fonts in two ways. First, you're going to use fonts for visual interest, right? You can immediately see single fonts, double fonts, cursive. If there are books like the alphabet artwork, lettering draws our attention, which is why you look at letters on posters and all that. So come up with 2 or 3 font types. Could be as simple as saying keep an uppercase and italics and a lowercase, or pick bubble lettering and cursive, doesn't matter. Pick a couple of font types. Keep them in your back pocket, practice them. Next, font sizes are for hierarchy. It's just like if you're familiar with web development, if you're familiar with mobile, any of those, right? Hierarchy, when you look at a page, you know what a section header looks like, you know what the subsection looks like. Same way, when you're writing notes, Big letters means this is important. Small letters means they kind of, you intrinsically think are subtopics within the big one. That's all you need to know. Practice your fonts. On each of these, I have some examples of places. I love these two books. They are incredible for giving you examples of really good posters. Next, quotes. We're still going on the theme of writing. So now you're writing stuff down. You figured out like handwriting and you figured out fonts. What should you be looking for? The art here is listening. You want to listen really intently. Like you don't want to capture every word out of the person's mouth, right? You want to listen intently. And if you're reading a document and distilling it from written docs, look or read intently to see where are the repetitions, right? Turns out that most speakers, most documentarians, they will use a phrase or a keyword over and over again if that is the crux of their talk, right? So look for those repetitions and make sure you write them down, and those should always be quotation sized because you know it's important. The person is saying it again and again. So write it down somewhere. You'll know why it is later. Also select for emotional resonance. The example here is this is Austin Kleon's Steal Like an Artist. I love this book. If you ever want to understand why we should be creative, you should read it. But what I liked about it, you can see these are my notes from the book, but the one that stands out is practice productive procrastination. I just love that phrase. I'm a procrastinator. But his point is that when you're procrastinating, you're actually uber productive, because procrastination is your brain mulling over things until a deadline hits, and then you know what you're going to do and you do it faster than you do otherwise, right? So I love this quote. That's what quotes do for you. That's the power of quotes. Next, you know, we've talked about text, right? So let's say at this point, you're able to capture information. You've got your fonts. You've begun to pick out your key takeaway messages and you've written them. How can you make this more visual? It turns out that when you drop people in your notes, they tend to, like, other listeners and readers tend to see themselves in it. They're like, oh, this is me. This is where I'm at, right? And later on, you'll find it's a way to add emotional resonance. You can make figures jump for joy. You can make them look happy, sad, right? So practice drawing people. Turns out people are not difficult. There are various kinds. Stick people that you see there, right? There are actually places in Pinterest. Pinterest is my friend here, where you can get like complete stick figures of everything, put them all down in a piece of paper, keep it with you, and literally look at it and draw it for that emotion. It's super simple. Stick people, star people. If you can't see, that's a star shape. List a star shape where the top is a head, right? Super easy. If you don't want to get into nuances, just know two things. Know how to draw a single person. You see the blob with the balloon on its head, that's a person. And then lots of tiny blobs, that's a collection. Those are the only two things you'll ever need to represent a person. Is it for a single person, individual case, or is it a group case? And if you memorize and kind of practice those two, you'll be set, right? So once you've got your simple person, then group, then focus on stick people or star people or anything else where you can do gestures, then work on faces and emotions, right? Great. So now we've come to the part where we're really looking at our sketch note and are like, how can I make this less cluttered? Because remember, till now you've been writing a whole bunch of notes, and I'll show you an example at the end. You want to make it simpler. Iconography. You can replace a lot of text with a simple image, especially if that image is something that people are familiar with. We are all familiar with icons. So in your domain or industry of choice, find a few icons that matter and practice them. These are very simple ones. Idea, podium for a lecture, a book, a video camera, a tree, a house, a factory, right? Whatever it may be. Build vocabulary for your domain. Noun project is my favorite. If you haven't seen it, go check it out. Designers all over the world put all their icons, and it's like you can use them with attribution for free, or you can pay a small price and you don't even have to like give attribution, right? But why I like Noun project is designers don't think about ideas the way you would. You can literally go there and look for an idea like happy camper, and it'll show you something that represents happy camper, right? So which is really cool. So icons let you represent a whole bunch of text with an image. And most importantly, now you've given it meaning. You've given that icon meaning. You can reuse it again and again to connect the dots across various parts of your notes. Containers are what you need to actually create clarity by putting boundaries around things that are related. So what do we mean by this? Remember, you were capturing notes all over the place. Now you want to tell people all of this stuff was about this one topic. Now this is about another topic. So to do that, you want ways to create contained areas. Again, Pinterest is your friend, or you can pretty much go look for any sketchnoting doc out there and it'll give you these examples. But come up with various ways to draw containers. It could be little clouds, it could be starbursts, it could be like, banners. Come up with some way in which you're creating containers to catch related topics together. Layouts. Containers are really about grouping things together. Layouts are about setting up the flow. How does a user go through all of this information? How can we navigate, or how can we kind of guide them through this information in a way that the flow makes sense? Because we are telling a visual story. So the two things you want to think about here, the next one we'll look at direction, but in the first one, we're going to look at constraints. Remember, I'm going to try to capture a 45-minute conversation on a sheet of paper. And as you'll see later on, I'm trying to capture, I think it's like 16 sheets of handwritten notes on Go in one sheet of paper. That's hard, right? So what you really want to think about is how much information do you have, and what's a good layout for me to capture this information in a way that people can immediately see the flow. And these are examples because you may not always know how much information is there. If I'm like taking notes for someone talking live, I have no idea if they're going to finish, like if they're a slow talker and they've only got 3 things to say, or if they're like me and they've got 50 things to say, right? How can I make sure I have space? So given these, right, like you can immediately say if someone's talk is called 10 things you need to know about blockchain, then you might do a hub spoke architecture. You're like, oh, I need 10 bubbles, and whatever they're saying, I'm going to distill into one of those, right? But if someone comes and says, I'm going to tell you the story of my life, then you're like, you know what, let's do a radial. We'll keep going with their story as long as they keep talking. And if I run out of space, I'll stop capturing their story and wait till I get the final message and put it in the middle, right? So that's kind of what that is. Direction is really about once you've got the containers and the flow, it helps to give people markers, right? Put arrows, put numbers, put colors, something that guides them along the flow you've laid out in case it's not really visible. And last but not least, color. All this time, I didn't mention color as much because you can get away sketchnoting with just a pen and paper. I do it all the time. Color to me is almost like something you add on. So color does 2 things for you. First, it can create visual separation. So if you look at the top one, that's me writing raw notes, right? I was literally capturing real-time chicken scratch. Bottom is me taking that, cleaning it up, and then making it look nice. I literally had to rewrite some of this stuff. But now I'm able to put like separations. Now you can see different islands are colored, and I'm able to connect things. So all the blue lines are colored the same way to mean these are all parts of a whole, right? So visual separation, so colors separate islands. Colors can connect things within an island. Most important of all, this is something that I'm really working on right now, is accessibility. When you talk about color, when you talk about visual, you're leaving behind a whole bunch of people who can perhaps see, or who have a contextual inability to see. How can we make this accessible to them? We need to have ways to kind of fit into that. That's another whole talk. I'll do that another day. But hopefully with that, you've got a toolkit, right? You've got these things that you know, if you practice, those are the tools you need to write your own sketch note. So now let's talk about sketch to learn. Somehow you learn to sketch and doodle and sketch note. What can you do with it? I am choosing to use it to teach people stuff and to help them learn. Because remember, my goal was visual learners. If you're learning technology, how can I make your life simple? So I want to give you a few examples of how I do this. First, we're all online now. This is the first example. You already saw this recently. This is from a conference called Create Data. Arun Ulag is the VP for the data product in Microsoft. He did a keynote. I kind of sketchnoted it live, then cleaned it up and shared it. And he's like, wow, this is amazing. This was rule number 1. You can capture notes live, refactor and share it. Why do you do this? 1, you are actually making that content available as a summary to all the people who may or may not have heard it, but to whom you think this is interesting. You're giving them an artifact they can learn from. Second, believe it or not, nowadays, all our interactions are online. This gives me a way to connect with people who are at that event that I wouldn't do otherwise. So you can go see all these tweets and all up there. Second, sometimes if you are, and this even could be for your own talk, if you know that your talk is pre-recorded and you're going to have it be delivered live, you can capture or create a sketch note from the recording ahead of time and then share it live during the talk. People will be like, wow, Like this literally happened to me 2 days ago. People were like, you did all of this live? And I'm like, no, not really. But sure, if it makes it look like magic, I'll take it, right? But the most important thing about this is that when people are listening to a talk, that's when they're really tuned into understanding what's going on. And on cases like Twitter, everyone's streaming lots of text and suddenly they're getting this visual. It's like a one page cheat sheet of the entire talk. They're like, wow, everyone wants to share it. Everyone wants to read it, right? So you can do that. Third, create talks. So I'm an advocate in the cloud advocacy team and I focus on mobile. We recently released a device called the Surface Duo. It's this dual screen device that you see. It has a 360 hinge. So I was doing talks on this, and what you're seeing there in the background, those 4 pages, those are the entirety of the docs for dual screen design in the Microsoft documentation repo. So I took all of those, wrote down all the notes, and you can see it's pretty dense. And then I actually distilled it down into a sketch note that if I can, I'll show you later. But what this did for me is from a talk perspective, I went out and gave 4 talks at top tier conferences. I was able to like plan my talk because I knew this is all the information I have to distill. By writing it down, I was able to then start slowly summarizing down till I got a visual. I'm able to see the big picture. I'm able to see the connections. I'm able to kind of step back and give people the high level perspective before drilling down. So you can see the notes on my raw notes on the left, the slide on the right. We already did this. This one, this is an entire module on cloud elasticity. We were doing an event where we were trying to teach people about cloud elasticity, where all the content is online. Again, same thing. The difference here is that when you're doing a workshop, think about it tomorrow, you're doing a workshop or a talk for someone, when they're done, you can give them a 1-page, here's the entire cheat sheet summary. And I actually will step back and say there are 2 value propositions here. Ideally, you want to give it to them ahead of your interactive session, and then you want to have them look at it after. Why? Because the human brain is wired to pay attention to words. When you give them a keynote, like a slide like this, you can look at this and you immediately know it's going to talk about load patterns. It's going to talk about scaling on demand, auto scaling in the cloud, load balancing. And there are keywords that are highlighted very strategically. Turns out that if you were to have read this sheet before you walked into the room for a workshop, your brain is already tuned to pick up those keywords. So when you're actually listening to the lecturer, you know the big picture, you've made the connections, you're paying attention and reinforcing things you know rather than, so think of it as a pre-read before a workshop and then a post-workshop recap so that should you actually have to take an exam later or try to apply it somewhere, you can pick this up and be like, okay, now I remember what they talked about. That's what this does for you. Last but not least, you can actually see them here. You can convert your sketch notes into zines, right? This is kind of very popular. So this is like, you can take the entire thing and print it out on one sheet. So this is just like my sketch note in a single sheet, except that you would make it up into cells, right? So you'd create 8 cells. And once you've done that, it's just a sheet of paper with a tear in the middle to fold it down, fold it together. And now you've got yourself a little comic that is passing your message out, right? Why is this important? Because A, it's still a visual, it's still visual notes from your talk or from whatever you're doing. Second is you get to control the takeaway message. More often than not, when people leave a talk, they're going to walk away with writing their own notes. They may have misheard, they may have misrepresented something. You want them to take away salient messages. You can literally give them a sketch note, but give it to them in the form of a zine. This is like your swag, right? Except it has reinforced the messages you put out there. And because it has only 8 cells, it kind of makes sure that you're constrained to what you want to say. So this, last but not least, you can actually go check this out on Twitter too. The summary of my entire talk is actually this sketch note. If you go right now to @sketchthedocs and you on Twitter and scroll through all of them, you'll find this there. This, the entire talk, I'm literally living what I told you. The entire talk, all the stuff I talked about has all been summarized in one page. And if you go to follow Sketch the Docs or go to cloud-skills.dev, you'll be able to download this one sheet. And because of all the words I said and because of all the flow I put together, when you look at it, you'll be like, okay, I get it. I remember this. More importantly, my specialty is high-res sketch notes. This is like 4K by 3K. I mean, 4,000 by 3,000 resolution. So it's a 4K sketch note. You can put this on a TV and see it. I literally have one somewhere here that is completely, it's a printed version. It's not over here, but it's printed on cloth, right? So you can kind of really do high resolution things, and we're trying to do other things with it besides. So with that, hopefully gave you a bunch of examples of what you can do once you've got sketchnoting skills. There are various ways to connect with audiences, help your own self, help other people, etc. If you are interested in actually walking through various aspects of this, feel free to, I'll share the slides with Andrew later, or they're all also online. Go to dev.to/t/visualize it. You will find that there are 6 workshops listed there against the tag. Each of them has a video online that's completely free, done by different community members, 2-hour workshops teaching you different skills that will help you. Everything from how to use Procreate on an iPad to like do a digital storytelling kind of asset, to how to do graphic recording, how to think like a graphic recorder, how to do journaling, etc., etc. So check it out. And the other side, cloud-skills.dev, you'll find all my high-res sketch notes. They're free for use. You can use them in your own blog. You can use them anywhere you like. You just can't use them commercially. That's all I ask. I'll put these out there, but you can also screenshot this if you want. These are the resources you need. If you're trying to understand why creativity, Austin Kleon's books are A+. Mike Rohde is the person that everyone credits with sketchnoting. So his books and workshops are really good. Then, once you've kind of got there, you want to pick different things you want to skill up in. Could be handwriting, could be diagrammatic map building, could be, kind of how do I do metaphors? So there are books around that, but you should also follow people. And I've picked 3 separate folks. First is Evalota Lamb, one of the best blogs for sketchnotists. She has so many ideas. She gives you so many kind of insights into how you can like sketchnote various things in various contexts. So great person to follow. Denise Yu for anthropomorphism. Denise actually does a lot of one-page visuals that explain concepts like Kubernetes using characters, right? So you understand how does adding a character help me create emotional connection to the concept being talked about. And then Maggie Appleton is really good for explaining visual metaphors. How do you take a technology concept and come up with a metaphor to explain it? And her way of thinking is, I want to frame that idea through a lens that belongs to something else. I'm like seeing you see the same idea, but through a window into some other object. And now you can start extending and transferring knowledge. Cool. That was about it. I'm going to leave you with 3 or 4 kind of wrap-up slides. This has been a very, very popular question when people come to me. They're like, what exactly is your process? This all looks cool, but when you put out these high-res visual guides, how do you do it? This is literally how. Behind there is an example. So on the right hand, that red one is the example I gave you for the cloud elasticity sketch note. It started out by me actually doing that entire tutorial myself. I go to the tutorial and I write it down, and it's all pen and ink, no color, no nothing, but you'll see it is visual. I've already got icons. I'm always sketchnoting. So I sketchnote the whole thing on paper, and then I look at the volume of information I have. This is kind of like my raw notes. And then I look at it, that's the capture. Then is the composition. What part of this is relevant to me? Do I want to put it all, or do I want to select what I want? So I compose it. I'm like, okay, I want this. I want to go from here to here to here to here, etc. Once I've composed it, once I've created a flow, I'm like, okay, I only have 8 areas to fill. Now I need to condense. I've got to take 4 pages and condense it down to 1. So now I have to think, how do I do it? A message to fit. I throw things away, or I replace them with a picture, or I find a different word that represents an entire sentence. Metaphors are great for this, right? Once you've done all this, the last step is clarity and creativity. You refactor this so that it looks consistent. You're not saying one thing here and saying something different. You're not using different icons. You're not doing different colors. Make it look uniformly consistent and clear. And the last but not least, that's always my +1. The thing is, this looks pretty. Everyone sees it. They're like, wow, this is awesome. But the true purpose was to get them to learn. So make sure you go through and say, what was my audience? What was my purpose? Does this serve the purpose? In my case, my purpose is, can I make you aware of this tutorial? Can I get you to walk through and understand key messages from it? And ideally, if I'm really, really good, you will go and finish the tutorial on your own, right? So that's my purpose. And am I actually driving that? So because this was Golang, I actually started on the process for a visual guide to Go. Unfortunately, I didn't get done in time. This is what the process is. You can see on the right-hand side, I have like 16 pages of notes. This is how I'm distilling them. So on the left is like where it is right now. It's kind of like, you can see that I think I've only distilled down 4 pages, and already 1/3 of the screen is full. but you can kind of get a sense of how I do this. This is like the time-lapse replay of my drawing of the giant sketch notes. So you can see, right, like distilling down, that's an entire page distilled into that column. So I'm like, I can't pick everything. I need to pick just enough so people can read it and then understand it. And then they need to go back to the source. The left side is really like, you know, characters kind of like, you can almost tell that this person is like exercising, right? It's literally an exercise. They're like starting with step one, going out, stretching, and then at the end, they're like done, right? So there's a story that's being told. And later on, unfortunately, I didn't finish it for today. But if you are interested to follow Sketch the Docs, I will be posting this as soon as it's done on that account. The link that it points to, which is the AKMS/visual/Golang learn, is the entire module associated with this. So if you really want to help me out, what I would love for you to do when I publish the sketch note is look at the sketch note, go check out the module, and then give me feedback. Does that sketch note help you complete the module faster? Am I actually helping or hurting by providing you this one image cheat sheet, right? And I'll actually be debuting it on probably on Learn TV at 1:30 p.m. on Thursday when I run a show called Hello World. So this might be part of that. But with that, I kind of will wrap this up. Thank you all for your attention. I'm going to eat my own dog food and always leave you with a visual summary of what you learned today. So hopefully you kind of took two things away from this. One is the learn to sketch. What is it? It's really about communicating ideas visually. Why should you do it? So you can learn. It helps you learn and retain information if you do it for yourself. But you can then take around and share it and teach other people using the same thing. Who can do this? Anyone. You don't have to be an artist. You just need to have some idea that you want to put down on paper. How do you do it? It's really about building a toolkit and practice, 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 practice. From a storytelling perspective, which is the other side of Sketch to Learn, it's really about how do I convey ideas or information to my audience? How do I foster deeper connections with them by giving them visuals and a story? How do I then motivate the audience to do something because of this? And ultimately, at the end of the day, if everything else fails, if all you have done is activated your audience's imagination, they're like, wow, this is so cool. Tech is fun. That itself, to me, is well worth being a message. So with that, I'm going to stop. Thank you all so very much for having me here. It's really, really late. It's 9 p.m. in Boston. So I appreciate everyone hanging around. And if there are questions, I'll take them. I don't know where they are. But otherwise, that's all I had for you. Thank you.
And thank you. I have a question. That was really awesome. One thing I'm wondering about is like I'm kind of a noob at drawing myself. I know I commented on one of your tweets with the drawing of cat bus that I made when I was presenting, which turned out to be turned out to still work for teaching about, I think, how like memory is used in Go slices. Yes. But one thing I'm wondering is I don't really have it's like spatial perception is kind of one of my weak spots. So I'm wondering how you know like about how much space you'll need to allocate like on the paper as you're drawing.
Yeah. So there is a friend of mine who's a graphic recorder, and she talks about this because she's one of those people who stands on the podium in a conference and she's sketchnoting the speaker live, and she has this giant board. In my case, I actually look at it from two perspectives. One is if you're digitizing, like if you learn how to use Procreate and using the iPad, then it's not a problem. You're just writing, and then if you run out of space, you literally go edit and stretch the canvas and keep going. There's literally, I think it was Chet Haas's Android keynote. I did that once because they had so much to say, I overestimated, and I'm like, I'll just stretch it out and add more, right? You can do that when it's digital because you can refactor. On paper, there are one of two approaches. This is what I was telling you about. I kind of, when I'm at a conference and I really, I'm not into it. I'm like, I'm not digging the whole topic. I just want to have a record of what I listen to. Then my approach is I always take a radial layout. So what I mean is I start from the top, like take a square sheet of paper. I write a lot. And then as I keep going towards the center, at some point I stop capturing what they're saying. And I wait till they finish and just capture the takeaway message. In other words, that's omission, right? You kind of like say, I'll omit stuff so I can get the takeaway message. I've captured the beginning, the start of the story, and I've captured the end. I'm missing parts of the middle, but I can connect the dots later. So that's one strategy. The other strategy is literally take 2 sheets of paper, and there's nothing that says a sketch note has to be 1 sheet. you can go on, and this is what I do when I do raw sketchnoting. I just capture as much as I need to. And then if I find it's relevant, and this is really for the talks that I care deeply about, I'm like, this is interesting. I need to learn this. I can't miss it. I'm going to capture everything. And then I'll come back and refactor it into one sheet, meaning that I might actually then pick up another sheet and redo some of the stuff so I can share it. If I'm not sharing it, I'm only doing it for me, then it doesn't matter if it's 2 sheets, right? But those are my 2 strategies: omission or refactoring, if it's paper and pen. If it's digital, it's really not a problem. You can just layer, and keep doing it. So for example, the Golang one that I'm doing right now, you can see I'm already struggling, right? It's like, you can see this, I don't have much space, and I've like got only 3 times as much information to fill in. I'm going to omit stuff, and that's okay. And sometimes what you can do, and this, people recommend this a lot, is you can use whiteout if you want and kind of replace a whole chunk with an icon. You can do lots of things. But the bigger picture is, it's not about capturing everything. It's really about helping you capture enough to pass the message. So to me, always leave space for the end message and leave space for the start. You can drop stuff in the middle if you need to. Don't quote.
That sounds great. Thank you.
Yeah. All right, if you have any questions, feel free to kind of ping me on Twitter. I'm at Nitya, my DMs are open. I also will kind of hugely recommend you check out at Sketch the docs if you want to see how different kinds of complex ideas. The main reason I love this stuff is that when you take something really complicated and you distill it down to a single sheet of paper, not only does it give people the big picture so they can decide if they want to learn it, but in reality, it makes it very accessible. You don't have to know the language to look at pictures. You don't have to feel like you have to understand the nuances of it. You know, like a 30-page documentation thing can kind of turn you off, but a picture feels accessible. And the whole idea with this is, let's make tech friendly, right? Let's make it easy for others to understand. So anyway, thank you so much. And hopefully when I'm done with this, I can come back one day and share the final version with you or send it to you, Andrew.
Yeah, thank you. That'll be awesome. I'll definitely retweet. And one other comment, by the way. Have you seen like this isn't like sketchnoting tech concepts. This is kind of like sketchnoting cats. Have you seen the account called like Poorly Drawn Cats? It's not actually poorly drawn. It's more like kind of like distilling the catness of the cat, like what makes the cat cute.
No, send it to me. You gotta tag me and tell me what it is. I want to go check it out.
Yeah, there's like some like really funny, cute ones on there.
Well, no, I even like your cat, because you know the thing with this, and this is what people always miss, right? They think it should be artistic. No, it should be memorable. I will never forget your cat. You know what I mean? And now that you've told me that slices, I'm like, oh, okay, I'm gonna go take another look. And for the rest of my life, I will make that association, right? And that is actually makes that particular cat more valuable.
That's awesome.
Yes, so I think that those are always the fun things, that it's like the meme generation, right? We infuse our drawings with our meanings. And I love putting Trojan horses. So that's one of my things, like I need to put Trojan horses in all my sketch notes to see how many people pay attention. But yeah.
Yeah, that's a good way to grab attention too. Like yeah, for me like my own go-to tool presenting for that is using like somehow tying the concepts I'm teaching back to sloths. Like I saw the Animal Planet special, just like they're so cute, and they had to be in my talks, and that's how they became kind of a personal content creator brand.
Well, my Trojan horse those are exactly the kinds of ideas we need to like, because it's not just about visual, right? It's anything that's creative and bringing technology understanding. So one of my things is like, I will deny it if you say it, but I'm like, I need to make Azure sketch notes like from Microsoft, where I'm hiding song titles from all classic rock artists, right? If I can get away with that, I mean, that would be so cool.
Nice.
You need to have like, characters should say something that if you read it, it's really like, wait, that's nothing to do with cloud computing. No, I'm kidding. But I love that. I mean, I think that's how we actually learn. That's how we make it fun. And honestly, That's how we'll remember.
Yeah, totally.
Anyway, I think there were no other questions, but always happy to come back and share all the stuff with you when it's done. And I guess that's what it